Okay, so we are now in topic 8, and we're going to start working on scenarios. So we're going to keep building on what we were doing before, but we're going to be doing the same kinds of steps over and over. And I want to talk about, in general, what are the steps that you're always going to look at, and I'm going to break them down into things that have objects at rest, constant velocity, whether they're speeding up or slowing down, so they have constant acceleration. So you are going to be on page 31 in your blue packet, and we're going to work on filling this page out. So I've got a copy of it up here. So first of all, step number 1, we want to always identify all the forces that are acting on the object. So remember, we had a types of forces sheet that gave us some information on that, but that's always where we've got to start. The second step is going to be drawing a free body diagram with all those forces labeled. We want to be sure we include the appropriate abbreviations so we're consistent. If we have any magnitudes that we can put down, we want to include that, and we want to include any directions that we know of when we're starting. Step 3, write down any additional information that you were given, such as mass or acceleration, so that you write down all of your known information right from the beginning. Step 4, you're going to ask yourself, does the problem tell you if the object is at rest? Or is it at constant velocity, or is it constant acceleration? So based on that information, that's going to help guide you through knowing what's balanced and what's not balanced. So step 5, so what does the information from number 4 tell you about the acceleration in the horizontal direction? Is there an acceleration? What about the vertical direction? Again, you're going to ask yourself, is there an acceleration, or are the forces going to be balanced? And number 6, what information is not already known? And this is where it can be helpful to circle or highlight whatever it is that you don't know, because at the end of any of these problems, you should be able to solve for everything. Okay, so then there's a couple of problem-solving steps, and I separate these because the previous stuff is really part of your problem setup, and the next part is truly the math that you're going to be doing. So one of those steps is going to be summing all of the horizontal forces, and you're going to be able to sum that the net forces in the x direction is going to equal to the forces to the right minus the forces to the left. And that assumes that rightward is the positive direction. Then you're going to sum all of the vertical forces, and you're going to do the same thing where the net forces in the y direction equals the up minus the down. So, and again, this assumes that up is your positive direction. And then finally, you're going to write your net force equations using Newton's second law of motion, which is the net force in the x direction is going to equal the mass times the acceleration in the x direction. So remember, we're separating our horizontal forces from our vertical forces. And then we've got sum of the net forces in the y direction equals the mass times the acceleration in the y direction. So what does this look like when we do a very simple problem? So I've got one example down here at the bottom, and we have a 15 kilogram box being pushed at constant velocity across the floor. So constant velocity should tell us that the forces are balanced. So that makes us realize that we have balanced forces horizontally and balanced forces vertically. So what I like to do when I draw my free body diagram is I like to make my box big enough to write the words or the numbers 15 kilograms inside of it. And then if I'm always writing it inside the box, I never lose it. So then I can say, what forces do I know that are acting on this? So if I'm looking back up, we've got number 1 that says identify all the forces. Let's see what all we can figure out. So the forces that are acting on this, well, we know we have gravity, the force of gravity. So F grav is equal to something, and it's going to be downwards. And then we know that we're going to have, since it's pushed across the floor, we know we're going to have a normal force going upwards. So F norm. Oh, I bumped my mouse, sorry. So what other forces do we know that are acting on it? Well, it said it's being pushed across the floor. Doesn't really tell us which direction, so I'm going to assume it's going to go to the right because it's positive. So let's put an applied force going to the right. And since this has to be moving across the floor, it's going to have friction trying to oppose the motion, so it's going to have the force of friction to the left. So that was step 1. Step 2, we don't know any additional information. So let's go, number 3 we've already done. Number 4, it's constant velocity, so we know we have balanced forces. Number 5, there is no acceleration. So the things we don't know are these 4 forces. So now we're going to have to calculate them. So we can calculate the force of gravity equals mass times g, the acceleration due to gravity. And our mass was written inside our little free body diagram, so it's 15 kilograms, and it's times 10 meters per second squared, so that gives us 150 newtons. So we can go back and fill that in our free body diagram. So the force of gravity is equal to 150 newtons. We do know that it's balanced, so our upward force of normal is 150 newtons. Now here is where we get a little stuck. We know that the applied force has to equal the friction force, but we don't know what it is. It doesn't give us any information. However, we can write that the applied force equals the friction force. If in a later problem step it gave us that information, we would be able to write that in. So that's basically using all of these steps in order to go through and work on the problem. So I am going to pause the video now, and then we will go on. We will do the at rest page. We'll do the constant velocity and constant acceleration page, and then you'll have some follow-up worksheets to do these on your own.